Okay, for the next problem, we want the probability of sum of two dice is 8. The sum of getting an 8 with two dice would be, you could roll a 2 and a 6, you could roll a 6 and a 2, you could roll a 3 and a 5 and a 3, you could roll a 4 and a 4. So there's 1, 2, 3, 4, 5 total ways to get a sum of 8 out of the total sample space, which would be 36. So this should be 5 out of 36. And the reason there's 36, by the way, is because there's 6 possible ways to get different things for the first one times 6 for the second one, which is 36 total. You could write all of them out if you wanted, but you can just multiply. Look at it as a tree diagram. You could get a 1, a 2, a 3, a 4. So you have 6 for the first branch times, and then you have the same thing for the second branch. You're going to times 6. That's a multiplication counting principle. Okay, now to get a sum of 5, you can have a 1 and a 4 and a 1, a 2 and a 3, a 3 and a 2, and that's it. So there's 4 out of 36. Okay, the sum of two dice is not 7. Let's find that the sum is 7 and then just do 1 minus that. So a sum of 7 would be 2 and 5, 5 and 2. I guess I could have done 6 and 1 and 1 and 6. And we've got 3 and 4, 4 and 3. And that's it. So 1, 2, 3, 4, 5, 6. So that's 6 out of 36. Just do 1 minus that, or 36 over 30, so it'll be 30 out of 30 out of 36. Okay, next the sum of two dice is 9 or 6. Those are independent events, so we can just add them up. So the probability of getting a 9 or a 6 is going to be equal to the probability of getting a 9 plus the probability of getting a 6. So let's find each of those individually. Probability of getting a 9, sum of 9 would be, you could do 3 and 6, 6 and 3. You could do 4 and 5, 5 and 4. And you could do, that's it. So that's 4 out of the total 36. And the probability of getting a 6, you could do 1 and 5, 5 and 1. You could do 2 and 4, 4 and 2. You could do 3 and 3. And that's it. So 1, 2, 3, 4, 5. So it'd be 5 out of 36. So that'd be 9 out of 36. All right, and the last one, the probability the sum of two dice is not 10 and not 4. Well, let's just do 1 minus the probability that we get a 10 minus the probability that the sum is 4, because the rest of it would be the not, those things. So 1 is 36 over 36. The probability that you get a 10, you can roll a 5 and a 5, a 6 and a 4, or a 4 and a 6 to get a 10. So there's 3 ways to do that. And the probability to get a 4, you can roll a 1 and a 3 and a 1, or a 2 and a 2. So there's 3 ways to do that as well. If you subtract, you get a 30 out of 36. Okay, the next probability, what's the probability that random drawing yields a green? Well, a green would be 2 out of the total 15. And then we're going to put it back, and that's followed by a blue. And a blue would be 4 out of the total 15. If we put it back, we still have 15. So that's 8 out of 225. You can put that as a decimal as well. And these are independent events because, you know, drawing a green is completely independent of drawing a red. Okay, for the next problem, it says real estate ad suggests that 6% of homes for sale have garages, 21% have swimming pools, and 12% have both. So I've labeled this accordingly. I've drawn the Venn diagram, and then, you know, the both goes in the middle, 12%. And if you subtract that from the garage, then 44% have a garage and not a swimming pool, and 9% have a swimming pool and not a garage. So that Venn diagram can help here quite a bit. So when it says, what's probably that we have a pool or a garage, that's this right here. And that's, you add up the two probabilities and then subtract the intersection. So it's 0.56 plus 0.21 minus 0.12, which we're going to do 65% instead of 0.6. And then if we're answering the question, neither a swimming pool nor a garage, if you look at this as the whole sample space, what's outside of here would be the answer to that question. So we want to take 1 and subtract 0.44, 0.12, and 0.09, and then give that as a percent. That's 0.35 or 35%. And the last question, a pool but no garage, would be right here. That'd be 9%. Next problem, let's just skip. We're not going to do a problem like this. We can skip 13. Okay, the next problem is pretty easy. It says a certain high school, if a student is selected at random and asked what they plan to do after graduating, here's the probability distribution. So if we're not going to attend a four-year college, then we could do all of these added up, or we could just do 1 minus the 0.1, which is 0.9. Attend a junior college. Probably that we attend a junior college would be right here, 0.2. Do not attend any college. Any college would be these three added up, which is 0.7. Okay, the next problem, problem 15, we're going to draw a Venn diagram here, but these two circles don't overlap at all because they're mutually exclusive. So that means that we don't, when we subtract for the probability of A or B formula, there is no intersection. So that's just 0. So there is no intersection between A and B. A or B then is just the two added up, which is 0.9. Not A is just always 1 minus what A is, which is 0.55. Not B is same thing, 1 minus what B is, which is 0.55 again. And then not A or B, well, A or B is 0.9, so 1 minus that would give you not A or B, which is 0.1. And then probability of A and not B, well, not B, since these are mutually exclusive, that's just looking for A, because not B is everything else. So it's A and everything else, which is just A. So we're just looking for A, which is 0.45. Okay, the next problem, if you write the conditional probability formula off our formula sheet, it tells you that this is 0.4, it tells you that this is 0.8, so you're just going to multiply to find what you're looking for, and so you get 0.32. Okay, the next problem, two cards are drawn from a deck. Probably the first card is an ace of clubs. There's only one of those out of the deck. And then if we don't replace it, there's only 51 cards left, and we took one of the blacks, so there was 26, but now there's only 25 black left. So we have to multiply this out, and that gives us 0.009427 about. All right, the next question, we want to rearrange the word poker, and the first letter P and the last letter is going to be an E. So there's only, if we say P is the first letter and E is the last letter, there's only 3 letters in the middle that we can rearrange. So 3 times 2 times 1, that's 3 factorial, or 6 ways we can do that. Divided by the total, which is 5 factorial. So it's 6 over 5 factorial. All right, the next one, 52 card deck again. If it's a 9, there's 4 out of 52 that are 9. A face card, not including the aces then, just Jack, Queen, and King. There's 4 of each of those, so that's 4 times 3 is 12 out of total 52. And then obviously just not a face card, just do 1 minus that. So it'd be 40 out of 52. Okay, the next problem gives us a list of numbers 0 to 156. What's the probability that we pick a perfect cube? Well, just write out the perfect cubes, 0 cubed through 5 cubed. 6 cubes too big. It's bigger than 156. So these are our only options. We have 6 out of the total 157. It's 157 because we're including 0. Okay, I'm trying to save time in the video, so I'm going to speed this up. But probability both are right-handed, be 0.86 times 0.86. Both are left-handed, be 0.14 times 0.14. Right-handed and left-handed, there's 2 ways to do that, so you got to add both ways. First, you choose a left-handed, then a right-handed, and if you choose a right-handed, then a left-handed. You have to double that, basically. And the probability that at least one is right-handed, we want to answer C plus answer A, because we could have one right-handed or we could have both right-handed. So you have to add both those answers. Okay, the next problem says a game of blackjack, the odds win is 0.47. So this is the binomial probability distribution theorem we were talking about, where if you want to find the probability that you win twice in 5 hands, that's this term of the binomial expansion for that I gave you in the notes. So that's 5C2. The probability of success is here, which is 0.47. You're going to win twice. You're going to lose 3 times. The probability of failure is 0.53. All right. Now, if you're going to win 10 or more times, you need to add up the 10th term plus the 11th term plus the 12th term and so on all the way up to 24. And the way to do that is actually looking at doing 1 minus the probability of the first 9 added up. And you're going to do it with your calculator, and I'll show you how. Go to second distribution. We want binom CDF. Okay, we want 24 trials. The probability of success is 0.47. Now x value is 9, but what this is going to do, it's going to add up the first 9. So winning 1 hand all the way up to winning 9 hands. So this will be all those added together. It's a cumulative distribution. So the probability that I win 1 hand plus the probability I win 2 hands plus 3 hands, all those added together gives me this. And I can do 1 minus that to get the probability that I win 10 or more, which is 0.7657. And the next I just repeat that, only with now a probability of success of 0.58 and a probability of failure of 0.42. 10 or more is the same thing, only this time I'm going to change my probability of success to 0.58 in the calculator when I go to do second distribution, binom CDF. I'm now going to change this to 0.58 right here. And then hit enter, and don't forget after you're done to do 1 minus that to get the probability of winning 10 or more. I'm sorry, 1 minus that, but you get the idea, and then it'll give you 0.9654. Okay, the next problem says a couple decides they have 4 children, the probability that they have at least 2 girls. So we're going to do probability of success is having a girl. There's 50% chance you're going to have a girl. And the probability of failure would be that you have a boy, which is also 50% chance. So if you do the binomial theorem, 4 girls would be this right here. 3 girls would be this term, and 2 girls would be this term. We need to add those up because those are all options that satisfy the condition of having at least 2 girls. So we're going to add those up, and you get 0.6875 if you do that. Now there's a way to do that in your calculator with binom CDF, but I'm not able to get it to work right now. Actually, I can. If you go to second distribution and go to binom CDF, 4 trials, probability of success is 0.5, and we want our x value to be 2 because we want to start off with 0, 1, and 2. So that'll add up the first 3 terms, I guess you could say, or having, 0 boys, 1 boys, and up to 2 boys. Or this is reversible, so this one you can really be flexible with how you enter it in, for my situation anyway. And then the next one is, what is probably all the children of the same gender? That's just the first term here, but you got to double it. So you end up getting 0.125 because the probability of this first term is 0.0625. That's having like all 4 girls, for example. But you have to double it because that same probability would happen if you had all 4 boys. So you got to double that. Same thing for the next one. 6 coins are tossed, so we're going to do 6C0. Probability of success, I'll call this a head, and failure is a tail. So 6 heads would work, 5 heads would work, and 4 heads would work. I want to add these together, which you can do in your calculator. Same thing if you do this time 6 trials, probability of success is 0.5, and we're going to add up the first 3 terms, so n equals 0, 1, and 2. Which gives you the answer you're looking for, which is 0.344 or 0.3438. All right, then the last problem. It's known that a certain drug causes side effects in 12% of the patients. So I did it like this, where I said probability of success is 0.88 because that's we want 0 patients having side effects or 1 patient having side effects. We want, in this case, 12% of patients having 12 patients having no side effects and 11 patients having no side effects. Adding those up, that would satisfy what they're looking for, which ends up giving you 0.5686, which is the answer. You can do this in your calculator as well. In order to do this one in your calculator, you have to do, there's different ways to do it because these are symmetric, like I said, but the way I got it to work is if there's, in this case, 12 trials, probability of success, this time I'll do 0.12. So we just want to do 1 because we want to add up the first 2 terms, 0 and 1. And that should give you the right answer of 0.5686. All right, I hope this helps.